In this lecture, we will continue the discussion on object-oriented programming. In particular, we will take a more careful look at the different types of variables, including class, instance, and local variables, and the group rules for variables. We will then start introducing branching statements, including the if-else and the switch statement. Let's first take a look at some examples to illustrate the use of different types of variables and their scope and lifetime in an object-oriented approach. Let's first take a look at what it means by the scope of a variable. The scope of a variable is the section of a program in which the variable can be used. We often encounter issues related to usability of objects in daily life. When we travel from place to place, we can use certain currency only within a particular region. For example, euro can be used in Europe, US dollars in the US, and renminbi in China. The same terms in different contexts could carry different meanings. For example, what you can get for $100 in Hong Kong is very different from what you can get for the same dollar amount in the US or Europe. In programs, you can declare multiple variables with the same name. In real life, we also often encounter multiple persons or objects with the same name. Actually, we have mentioned in the first lecture that there are several cities with the name London, and we can find out which one is being referred to from the context. Say, if you're in England, you are probably referring to London in the UK. If you're in Canada, you are probably talking about the London in the province of Ontario. Another example is the use of usernames in different domains. Although your username on the edX platform is unique, the same username may have been used by a different user in another domain. In my case, I must have made at least 10 different attempts before edX accepted that the name that I enter had not been used before. Let's look at the scope rules for different types of variables in Java. First of all, Java is a strongly typed programming language. That is, all names must be first defined before they can be used. We have introduced instance variables last week, and we will talk about statics or class variables later in this lecture. They are declared outside the methods and are accessible from anywhere within the class where they are declared. Whether they are accessible outside the class will depend on the access identifier used in the declaration. Variables declared inside method, including the parameter variables, are accessible only within the method. They are usually referred to as local variables, and access identifiers are not allowed for local variables. Local variables also have short lifetime. They are created when the method call is made and will be gone when the execution of the program is completed. Variables declared within a program block and closed in a pair of curly braces are local to the program block. That is, they are not accessible outside the program block. Now, what if you have two variables declared with the same name in a program? The way Java deals with variables with the same name is to first attempt to find a matching variable declaration in the current block where the variable appears. If such a declaration is not found, an attempt is made to find a matching variable declaration in its parent's block. This process will repeat until the scope of the variable is resolved. There will be compilation error if the variable name cannot be resolved even in the outermost block of code. Let's first take a look at a simple example, namely the bank account class that we have introduced last time, to illustrate some of the scoping ideas. There are two instance variables, balance and owner, in the bank account declaration. According to the scope rules for instance variable, they are accessible anywhere within the class, and you can see that balance and owner are being used in the second constructor. And balance is used in all the three methods: deposit, withdraw, and get balance. Notice also not only that the method can access these instance variables, they can also make changes to their values. For example, deposit could increase the value of balance by adding the amount to be deposited to the account. Here, both the method deposit and withdraw have one parameter, one with the name DAmount and the other WAmount. As described in the scope rule, parameter variables are local variables. They can be used only within the corresponding methods. That is, the method deposit will not be allowed to access WAmount, and the method withdraw will not be able to refer to the variable DAmount. Now what if we change D amount and W amount to the same name amount? This would be fine because amount in deposit is local to the method deposit, and the parameter with the same name amount in the method withdraw is resided in different memory space than the parameter amount in deposit. That is, the program will not mistakenly subtract an amount from the balance that was supposed to be deposited to the account. Let's do another modification to the withdrawal method by replacing the name of the parameter variable amount with balance. Perhaps you can think of this as making a withdrawal from a piggy bank. You have to break the piggy bank and take out the entire balance. What do you think would happen if such a withdrawal is made? Would that actually deplete the account? Let's go to BlueJ to take a look at the execution of the program.